Awesome. Welcome, everyone. My name is Dev DeVrat. I use he, him pronouns, and I'm the Associate Dean of Admissions here at Reed College. Excited to be moderating this session for you. And I'm going to pass it over to Allison to introduce themselves and start with our presentation.
All right. Hi, everybody. I'm Alison Crocker in the physics department. I use she, her pronouns, and I've been in the department and here at Reed for 9 years now. My own personal research is in astrophysics. And so I teach courses in astro, but also within the physics curriculum. And I'm currently chair of the department. So I wanted to start with, exactly as Dev said, just an overview of what the physics major here is all about. So I'm going to share screen so I can show some slides, because I think that's a helpful way of seeing what courses you'd be taking if you were a physics major here. So I'll go ahead and share the right screen. Okay. All right. So I think now, if I do that, is that still working for everybody? Yeah, great. All right, so here's the general layout of the physics major, and I'll focus first on the first 2 years. We have a pretty linear sequence of required courses. Physics 101 is a calculus-based general physics course covering mechanics. Physics 102 goes on to electromagnetism in the spring semester, also calculus-based. And then the second year is an oscillation and waves course and a modern physics course. The math that goes along with that is calculus, which is a co-requisite if you haven't yet taken it. If you have, you might place out of that. That's fully math department dependent. And then introduction to analysis, linear algebra, and vector calculus round out the math requirements for the physics major. The next third and fourth year are where the third year is really, we put a lot of our required courses in that year. And we do that so we know that everybody has this basis from which to start on their senior thesis. So we cover sort of this core intermediate to advanced level curriculum all in the junior year with 5 different courses, 2 advanced lab courses, both in fall and in spring, and then classical mechanics, electrodynamics, quantum mechanics 1. There are advanced versions of all of those courses that are electives, but this is the first round at those more advanced topics. And then the fourth year, the really only required thing for the physics major is the senior thesis. But so putting that I won't go over this in detail, right? You do have time, you fit in a Hume 110, and you fit in other group type requirements that we have here at Reed. This is an example of how you might do that. Beyond those required courses, these are our common electives, and all of these are offered either every other year or every year. And so you get a shot at nearly all of these. Everything in the left column is offered every year. Things in the right column are generally only every other year. But you will always have some mix of the right column in any junior, any senior year that you can take. So it's one of the things that makes our program at Reed fairly unique for an undergraduate liberal arts program is really the depth of the classes we're able to offer, because we have a fairly large number of physics majors per year, around 20. We can actually really reliably offer this upper level curriculum that not all places can. Some other places you might only get quantum mechanics, the first version, every other year, but we solidly have that every year, and there's 20 other students with you in it. And we also have quite a bit beyond that basic upper level course. So thesis, you've probably heard a little bit about thesis at Reed, but right, it's this year-long independent research project. You choose the topic, you're mentored by one of us faculty, you write a document. We have seminar talks in physics, so we get to all hear what cool things our seniors are doing, even if I'm not the advisor, and that's going on right now, so it's very fun. So we've had recent talks from all of our seniors, and there's 2 more editions coming up, and then there's a defense at the end of it. And here are just a few recent examples of some cool theses. People have really different interests, and you are armed with a lot of physics tools by the time you're a senior here. So from sort of geophysics type stuff to astrophysics. The second topic worked with me on counter-rotating disk galaxies, to quantum, like pretty intense quantum mechanics, for these final two. So stuff, yeah, you get to do interesting stuff by following that path of taking quite a lot of core physics in your junior year. Here's the department, here are faculty in the department, and our sub-research field. So Mark Beck works on quantum optics and laser physics. He's currently away, but would be back by the time you might be thesising. Noah Charles works on condensed matter theory. Aaron Cook is atomic physics. As I said, I do astrophysics. Joel does general relativity, quantum mechanics. Jennifer does experimental solid-state physics. Luke is nonlinear dynamics, optical and atomic physics, and Daryl does sort of condensed matter theory and quantum information. So we have, we can't cover absolutely every topic as a small department, but we have a wide range of interests. And we generally also advise theses outside our exact zone of interest. So I've worked on theses that are covering the physics of avalanches, for example. So if you have a passion project that you develop over your time here, that's still something that we can fit into a thesis project, even if it's not exactly what one of us work on. We also have things beyond courses. So one of the things I love about our department is we have a really well-attended weekly seminar. And we use this in a variety of ways. At the beginning of the fall, we have students coming back from various summer research opportunities that they've had, and they present in fairly short talks, 10 minutes, what they were up to over the summer. And that's great because we as faculty here and the younger students here, and they maybe think of trying something related to that, or it can apply to that program. Then through the core of the year, we use that weekly seminar to invite outside speakers that are in different topics, that are doing cool things. We always have some from also fields outside of academic physics to give people an idea of what different career paths people might follow that do physics here at Reed. And at the very end, we have what I was talking about now. We have seniors presenting on their thesis research to round out the year. And so we meet for sort of coffee and hot chocolate and cookies beforehand for a half hour in the physics student lounge. And then all head to seminar and listen to seminar. So that's a really great weekly activity. There's research opportunities within the department. A lot of that happens over the summer, but we're also, a few of us do take students during the year on specific projects that we have funding for. We also have a lot of jobs within the department, which is, if you're interested, a way to both get paid to do work and in a way review more physics, so it can be a win-win, and it's a way to be also part of the department. And then there's a few different astronomy things, and I mention it not just because I'm the astronomer, but there are also more events that bring people in. I have a weekly astrophysics discussion group, and we also have a telescope on the roof of the physics building that people are welcome to get trained in and learn how to use on their own. So that was the most of what I wanted to present. So let me stop share and just come back to talking. I think that was the major points, and I'd be happy to talk about people's questions from here on out.
Yeah, thank you so much. Starting off, some of the questions here, and great questions, y'all, keep them coming. Are there any professors, you talked a little bit about the specialties that each of the professors have, and you did talk some about quantum mechanic. I apologize if this is an obvious answer. I'm not as familiar. Is that the same as quantum gravity? And are any of the professors focused on quantum gravity as like a specialty or area of interest or focus?
Not super specifically. So we have people who are interested both on the gravity side and the quantum side, but not tons in specifically quantum gravity.
Great, awesome. And then, I know that Reed has that 3-2 program with in engineering in particular. And I know that's pretty heavy physics coursework. Um, I'm pretty sure I'm confident with this answer, but can students do some sort of a 3-2 combined program with physics through one of these partner institutions? Or any partnerships with other institutions through our physics department?
So yes, so we have a 3-2 agreement, and formally there's one with Caltech, there's one with Cornell, and one with Rensselaer Polytechnic. So those three different, we're looking into some others. Basically the Caltech one you should consider defunct. And I'll focus on the other two. I know Cornell also has an applied physics option for a 3-2 program that you can do the 3 years here and then 2 years towards a master in applied physics. And we did have a student do that. Now it's 4 years ago. They actually fully graduated from both programs recently. So that's been, most recently, we've had students go to Cornell, both for the engineering style 3-2 program and an applied physics 3-2 program.
Very cool, thank you. How early would a student be able to participate in research? I know you addressed some of that, but how soon can that happen? And then how competitive are those research opportunities?
Yeah, so it can happen in the first year. I won't say that's terribly common. A lot of our research efforts are towards this required senior year thesis that we're there during the school year, but some of us do have labs that are open to students during the school year as well, because there's things to get done. Is it competitive? I guess I would say yes, because there aren't terribly large numbers of those opportunities. So we do have more students interested than we're able to line up with research opportunities during the school year. But we really make it a point for over summers to try to expand those opportunities and have both more for our students here at Reed and also make clear that there's many different things to apply to over summers to round out research experience.
Awesome, thank you. We have a couple of questions coming in about the nuclear reactor on campus. Do you mind shedding a little bit more light on how that works, what the process is, how involved students are with the reactor, what opportunities they might have?
Absolutely, I will do my best. So, fun fact, it's totally student run. I mean, there's a staff member who is the director and helps the students with ongoing operations, but it is not something that is in the physics department in any way, shape, or form. It's also not in the chem department. So it is there. It's a great thing that people can get involved in, but it is quite separate from the academic program. That said, it's a lot of work and learning. There's a lot to learn about in the reactor program if you're interested, and it takes a fair bit of time, and you get a fair bit out of it because you're learning a bunch. And so that is also something definitely unique to Reed, and it's absolutely physics. So some of our students, I would say probably a third or so of physics majors are involved in the reactor program. So it's pretty common for physics majors, but it's not everyone. And some smaller fraction of that third become really interested and do senior theses adjacent to nuclear physics or really properly in nuclear physics. And there's other things that go downstream of that, like medical physics. So I think we see a good deal more of that than other similar schools because of the reactor program.
Awesome, thank you. Going back to the 3-2 program, how many students do you think do participate, do go down that route? So that's the first part of that question. The second part of the question also goes back to the research availabilities. Are there internships that are physics related that students typically participate in? Like as research assistants or internships outside of Reed, Do those typically happen in the summer or between the first and second year? Is that usually between the second and third year? When do those typically happen?
Okay, I'll try to keep both parts in mind, but if I forget, Dev, let me know. So first, it was about the 3-2 program and how common that is of actually occurring. It's not terribly common, is the real answer. And why is that? So many students there are more students who come in interested in it than actually end up following through. And from working with these students, it's more because students decide that there are ways of going after being an engineer that are better for them than the 3-2 program, that they'd rather finish their physics degree here at Reed, actually have the experience of writing the thesis, and then go and do a master's in engineering just afterwards as a separate thing. So the program exists. I would say on average, we had 1 year about 4 years ago where we had 3 students all at once, and that was very atypical. We haven't had anyone since. So 1 every 4 years, 1 every 3 years is the rate that we've actually been sending people. We've had a few more people apply, but they apply and then have made the decision to stay. And so it can be a hard decision. I know students who have gone back and forth and know that they missed out on something when they went one way, or are here and are like, well, now I got to figure out how to do engineering this other way. So it's a mix of things. I will also say on the subject of 3-2, it's a lot of coursework to fit in the 3 years you're here at Reed, to both meet all the Reed requirements and all the requirements for admission to the 3-2 program. And that is also something that sometimes can dissuade people because they don't want to be sort of overloaded all of the semesters they're here. So there's a few different reasons, but I'd say mostly people who are engineer interested can still do so with sort of a 4-2 or some other combination of years at places to end up heading down an engineering path.
Awesome, thank you. Is it possible to place out of the first year physics classes or like test out of them?
Okay, and Dev, I'll cover that, but I think I realized I forgot the second half of the question. So if you can remember that for me and repeat it. So to talk placement, I'm happy to talk placement. So it is possible. We, for the first time, are going to use AP scores as a first measure because the APC is a calculus-based physics set of things. So the mechanics and the E&M sections separately could place one out, and this is the first time we're going to try using these, and so we're setting the bar high. The bar will be a 5 on the AP exams. If you have a 5 in both APC mechanics and BC calculus, then we're happy to use those to place you out of Physics 101. If additionally you have a 5 on the E&M portion of AP Physics C, that would additionally place you out of 102. If things have not allowed you, if you've had a calculus-based, really solid physics course, if you haven't had a calculus-based one or feel at all iffy, just take the introphysics sequence. It's not worth trying, if anything is iffy, getting ahead, because having a deep understanding of the basics, and it will be a fast calculus-based course, it will not be boring, is really important moving forward. But if you have had a really solid calculus-based mechanics course and have solid calculus skills, we will have some sort of testing available during orientation week that lets us see that. But the AP scores is kind of the first and foremost thing, and that's a follow-up if that isn't possible for some reason.
Awesome. And then jumping back to the part that we missed, it was around like internship opportunities, or I'll even throw in research. What kinds of internship opportunities are available? Are those on campus? Are they off campus? What do you typically see students doing? And when do these occur?
Yeah, I think it's very common. So I think many students get them between the sort of sophomore to junior year. The first to second year is still, it's hard to get anything really on campus or off campus. In physics as a field, it helps to know more of the basics before diving into research in most, but not all cases. And so it becomes easier and easier as you go on to get summer internship research opportunities, is the truth of the matter. And that is true both sort of in-house and for other outside of Reed opportunities, both like RUs and things that might be internships at companies. So the sort of the fraction of our students that are doing those definitely increases summer to summer.
And sort of off of that, are those internships also eligible to be work studies? Or what are the work study opportunities within the department?
Totally. So sometimes the research work is work study. More often, you can do work study work within the department, as some of these jobs we have as grading or being a lab TA. People love being lab TAs. They share their knowledge with the sort of next set of intro physics students. There's also tutor positions all within the department. And so all of those are work study eligible. That sort of also, while you're doing work, sort of also help you solidify all of the physics information, because they're all roles that are in some way teaching, and that always solidifies your understanding best, trying to teach something to someone else.
Awesome, thank you. Can you talk about interdisciplinary majors that coincide with physics? So, what are some of the common ones, and how likely is it to do an interdisciplinary major with physics?
Absolutely. So we have a fair few of ad hoc math physics interdisciplinary majors each year. And every once in a while, a chem physics. Those are the most common ones that we see. Probably they're some of the closest fields, so it makes sense. And what does it mean? So what it means at Reed is really that you want your thesis to be in a place where those fields overlap. You can still, right? You can take all of the coursework you want in math and physics and either be a physics major or a math major, and that's all good. But if you want to be a physics math interdisciplinary major, it means that you want your thesis to land in that zone between math and physics. And so it does cut down a fair bit on the total number of options for your thesis. And that's really what we ask students to commit to. This is a declaration that's done in your sophomore spring, that no, I'm not interested in separately physics and math, because both are super cool. I want to narrow myself down to this intersection zone. That's kind of what an interdisciplinary major means, at least for us.
Great, thank you. And then do you mind elaborating a little bit more about the junior quals? How challenging are they? Do people fail? What happens if people fail?
Yeah, totally. And I may have an update, but I will report on the current status of everything. So the current status is that the junior qual is an exam held at the beginning of the junior fall year. And what it covers is really only the physics material from those first 4 courses that I put up. So just 101, 102, 201, 202. And so we do at that point think it's important that you know all the material from the first 4 courses, because you're going on to harder and tougher material in the junior year. So that's why we've pushed it. Other junior quals for other departments are commonly in the junior spring. We pushed ours earlier because that's kind of when it's important and relevant for physics, is to commit to the idea that you've consolidated that information and you know it heading into these junior level courses. It is not common to fail. It happens once in a blue moon, and generally it happens with fair warning, as in someone's not, if someone is barely passing these 4 courses that lead up to the exam. So it is not something that would happen like out of the blue. If you're doing perfectly fine in all of these 4 courses that the exam is on, with some studying, the exam will go just fine. And so I really tell people to, your only job leading in the years up to that junior qual is to just be an honest, awesome learner in those courses, and then you will do fine on this junior qual thing.
Awesome, thank you. What advice would you give to someone, or maybe some suggestions to someone who maybe went the homeschool route and is interested in our physics program?
Cool. And I mean, it would pretty quickly go to a pretty individual conversations just to gauge where exactly the what you've studied will set you up to head into our program. But in general, I mean, it will be new and different if you haven't been in a classroom spaces tons for your high school curriculum. But I think that there's a lot of independence that one gains as a homeschool learner, and that will continue being a benefit to you throughout our program, even though it is classroom based. When push comes to shove, it isn't your passive engagement in a classroom that's the important thing. It's your active engagement. And I think that's what homeschool learners have had to do a lot more of. So I think it sets you up really well to learn the tough material that would be coming down the road.
Yeah, that makes sense. You touched on a 4-2 program, or you mentioned 4-2. Could you elaborate on that? It also looks like this person says that, according to your faculty list, most people seem to do a master's at different school. Could you share a little bit more on that as well? I'm not sure if they're referring to the faculty or just students, primarily because we don't offer master's programs in outside of our liberal arts master's program. So I don't know if that was my
So,
interpretation of that question made sense.
and person can speak back up in chat if they need to clarify. So when I said 4-2, I just meant you do the 4 years here, and then you can choose by applying and going a fairly normal route. It may be something that comes down the road and we work out formal 4-2 or other 3-2 agreements, but we don't have any that are formal agreements on the books that would be like 4 years here and 2 somewhere else. So that's just what I meant by 4-2 is do 4 years here and then 2 or possibly 3, depending on what engineering subfield to get a master's in engineering. Yeah, so that's what I meant by that. Was there another part of the question, Dev?
No, I think that was just me rambling to get the question out, but I think you got it. Awesome. Going back to research, lots of interest in research. What are some of the student research looking like in terms of the similarities and differences between experimental and theoretical research?
Well, it depends a lot on how much you'd go to lab, right? So theoretical research, a lot of that is asking computers for help in tough theoretical questions. So much more frequently, theoretical work is going to be doing coding work to work on these interesting problems in theory. And experimental work can range from being pretty computer-based, if there's already data around, to fully in the lab, standing on your feet, making things work, designing new systems with Mark doing quantum optics, like single photon measurements, or working with Jennifer on characterizing 2D materials, or working with me and trying to sort out this telescope data. So yeah, it can vary a lot. But computers are part of all of these things these days. And so part of the curriculum here at Reed is we do have sort of computational methods baked into some of our required courses, as well as have a computational physics elective that helps you tackle higher order problems with computational methods.
Awesome. The next question is, how is the placement scenario post-graduation for physics majors like? Um, Before I pass over to you, I will also just say, and maybe this is also your answer as well, but typically we have an office here at Reed called the Center for Life Beyond Reed that helps work with students to sort of navigate post-Reed, post-graduation uh, paths. That could be, and I'm assuming that's what this question is referring to when they say placement scenario post-graduation. I think maybe I'm a little confused on that term. Um, Unless you have a different response, but how I'm interpreting it is postgraduate opportunities, where Center for Life Beyond Read really works with you on an individual basis to navigate what those details might look like for you individually, whether that's pursuing additional education, going to the workforce. They can help you navigate those opportunities based on what your goals and objectives are. But would you add anything to that?
Not really, right? I mean, and we really partner, there's things for students who are more interested in graduate school, like I think the faculty do more of the advising. And for options beyond that, Center for Life Beyond Read does more of the advising. But everyone should look into the options that are even possibly relevant. And so even for my students who are super interested in grad school, I was like, go talk to the Center for Life Beyond Read, because you just want to know what the other options are and have a sense of what the field is like. And I actually think it's great when people take a year off between Reed and graduate school, because that lets you know you can be a successful adult in the world with the skills you already have. And then you move on to graduate school and you have your thesis advisor from your finished thesis able to write a really good letter. And you just go in with a little bit of a gap from hard work your senior year here, and just having that sense of, I know I can be a successful adult human out in the real world. And that, I think, gives people a mental resilience that is helpful, because in everyone's graduate career, there are tough moments. And so that's my little recommendation. But that's just me. That's a little opinion.
Awesome, thank you. What about students who are interested in taking a minor at Reed? Do you suggest, yeah, so does opting for a minor at Reed take away from how many physics classes a student can take? And then do you suggest focusing on just the major and not trying to straddle between different interests and different subjects? I'm assuming in related to the minor.
Yeah, it is up to you. And right, even future you can't be sure about what you'll want to do later. So it is absolutely possible to minor. I think we have an English minor graduating this year and a German minor. Does that cut down in some of the possibility of taking more physics? Absolutely, because there's only so much room. But I think that's true anywhere. I don't think that's unique to Reed. You have to there's a certain number of courses that are not determined by your major or the group requirements. And it's up to you what to do with those. And part of the awesomeness of a liberal arts school is that you have many options. And one of them would be going super deep in physics and taking all these physics electives. We have enough to keep you busy. But a totally other way would be doing, even multiple minors, I think, would just barely fit in, depending on which ones. So, right, there's a wide array of things to do, and people do all of that. Physics majors here some take absolutely every last elective they can, and some do the junior required courses in their thesis, and then are totally doing courses outside of physics otherwise their final 2 years. So everything goes, and you'll figure out your right path.
Great, thank you. Conventionally, it seems that most classical mechanics courses in college require students to take differential equation, but that does not appear to be the case here at Reed. Can you elaborate on that?
Totally. Our Waves and Oscillations course, Physics 201, teaches enough differential equations for the upper level physics courses. So that's where that sort of required bit of knowledge is actually covered in our curriculum.
Great, awesome, thank you. And is medical physics a pathway that is possible here at Reed? Have students pursued here at Reed?
So particularly because, a lot of medical physics is is nuclear related or adjacent, a lot of imaging. And so we have probably a student every other year who's becomes quite interested in medical physics. So we do have a number of alums who are in the fields now, which is great. We, other than having a nuclear program and having the physics courses, we don't have any specific medical physics programming, but I was just approached by a student yesterday, actually, who wants to do a medical physics independent study, and we'll find a way to let her do that. None of us are exact experts, but an independent study, the faculty member doesn't have to be. The student proposes the program of study, and we're mentors to guide the student on that path of learning. So those are options, and I would say that Oregon Health and Sciences University, which is really nearby and across the river, top medical school in Oregon, is a place that internships and research work that might help someone get a taste in medical physics have happened in the past, and I'm sure it could continue happening in the future.
Awesome. The next question, I know interdisciplinary majors are way more common here at Reed than double majoring. Can you elaborate on the difference? And how would you recommend students choose between the double major versus interdisciplinary major in two different fields, for example, math and physics, both in terms of coursework and focus?
Yeah, so start out by taking, in the first 2 years, all the math and physics you want. And then think about it 2 years in, whether you want to write a physics, as I said before, in that in-between zone between math and physics, or very boldly want to write 2 whole independent theses. What does that mean? You'd write a thesis in math that would be both a full credit course your fall and spring semesters and of your senior year, a full physics and thesis, which would be a full credit course both in fall and spring semester of your senior year. So why that option is so uncommon, I think it's not because Reed students are lazy, because they really aren't, but it's because most students realize that they, instead of doing that full year program of a thesis in both fields, that they'd rather take more coursework, because there's really cool upper level courses both in math and physics. So most choose one or the other or the in-between zone and only write one thesis. Since I've been at Reed, no one has done a math physics double major. I've known of, I think, 2 double majors, and they were actually, well, one was math and philosophy. And the other one I'm thinking of actually in the end did not do the double major. They were going to do physics and philosophy, but they pulled back from the philosophy side at the end.
You don't happen to know the implications of financial aid. I feel like this is a question I probably should know, but someone who was like doing a double major versus a interdisciplinary major, because I'd imagine perhaps a double major would take a little bit longer. Maybe.
So then there's whatever financial aid implications there are of taking an extra semester, which I'm not expert on,
Okay.
but generally the people I've known who've actually done or planned for the double major figured out ways to fit it in a normal set of semesters. It does take overloading, probably. And it depends a little bit on the fields, and it depends if you had any credits that came in as placing you more advanced in math or physics.
Yeah, okay, that makes sense. And that's what I figured. I think that would be a question more for the financial aid office anyways, but yeah, appreciate that. Okay, so kind of a multi-part question, or maybe not. Just doing an interdisciplinary major like math or physics or chemistry and physics, are you sacrificing depth by increasing breadth? This particular student would, kind of hate to miss out on some of those higher level math, chem, or physics classes just because they wanted to do more.
I'd really, does it count as missing out? I mean, in a certain way, yes, there are just more required classes that are probably not at the highest level, if you're doing one of these interdisciplinary majors, there's more up to the 300 level. We generally code courses by kind of year. And so 300 would be typically junior courses, but definitely seniors take them as well. Whereas a 400 level course would be almost only intended for seniors or someone who was sort of ahead in their progression. So yeah, you probably in doing interdisciplinary or double major would have less room for those particularly 400 level electives. And it's just the way that, there's not infinite time, unfortunately.
Yeah, totally makes sense. If a student wanted to do independent study that a professor doesn't specialize in, but there are several textbooks written by experts on that subject, would the independent study be the professor decoding the textbooks and helping you through it? But would it look different? Can you maybe elaborate a little bit more on that?
Yeah, independent studies can take a ton of different forms, but particularly if it's a field that is not in faculty members' expertise, it's going to take the form of finding a textbook or other series of reputable sources. Could be a series of junior journal articles that had a particular direction that the student collects and writes a proposal that my goal is to go through this material in this way. I will meet generally weekly with a professor to go over my solutions to the problems, my questions about the things. And generally they're only half credit courses, because if someone's not an expert in it, it's hard to, from our side, make sure that there's enough in the course that it is a full credit style course. So it's generally a good way to explore, and we'll be pretty flexible if there is some sort of good source, like a textbook that is pretty reliable that a student can work through. And yeah, generally it would take that format of meeting once or twice a week to go over the material with the student. Other independent studies can take the form of being related to research of a professor during the school year. But then those are really only for junior and senior level students, the independent study route.
Awesome. I know that Reed, a lot of our classes tend to be we refer to as conference style learning, right? Can you tell us a little bit more about how the class structures work in the physics department? Does it still have some of the elements of the conference style, and what that might look like for a student?
Totally. So it would help. Physics 100 is different from all the rest. So Physics 100 is taught as a fairly large lecture of all interested students in the big lecture hall as the primary 3 times a week thing. But then it also has lab, which is probably not unexpected. And then it also has what we call conference, but takes a different look than Hume conference, because it's mostly problem solving in small group sessions along with a real professor. And this is a difference between Reed and maybe schools that have graduate programs. In those schools, it would be graduate students doing these kind of intense problem sessions. But here it gets to be the actual professors of the course and other professors. And so I just had conference earlier today. And so my 15 students all divided into 5 groups of 3 and worked on these different problems on the blackboard, and I kind of go along around and checking in with them, helping when it's needed, letting do their own work when it's appropriate. And so we have that higher contact with students in that way, weekly in those conference sessions. So that's for that full 100 year, it takes that format. And then starting in 200, the classrooms are generally kind of those 20 to 26 other people who are physics majors. And so that's a typical size. Things that aren't required might be lower, like in the lower teens for the electives, but it's generally like a pretty well-populated room. And different faculty take a mix of different methods. There is a fair bit of still lecturing, but breaking it up and making some active problem solving sessions happen as part of that lecture, because it's not a huge room. It's actually in the same exact room that we do the conference work in. So there's tons of blackboards around. So things happen a bit differently. The only other exception to that general lecture-ish, but with breaks and definitely room for questions. We all love questions. Are the upper level lab courses, which are taught as lab primary. And so there's a lab lecture every week, but the primary course is the lab period. So those junior lab courses work in that way, where there's an hour lab lecture and then 3 hours of lab, one afternoon a week.
And what does community building look like in the physics department? How are students supporting each other and interacting with each other? How does the classroom, kind of you touched on the kind of the classroom community, but just sort of overall department like community relationship building look like?
Yeah, and I mentioned some of the events that we have, and those go towards that, like the meeting before seminar every week with students and faculty and staff. That's great. We all see each other, check in, talk physics, not talk physics, whatever. And so that's a good social time. And then we do have the physics student lounge on the ground floor is pretty well used for students to hang out with between classes, get together with other people and work on problem sets with. And so, yeah, we have those spaces and events that help out. We also have like when people are sort of sophomore fall, more sure they're going to be physics majors. We have a sophomore bowling event that lets more of the students in the sophomore year meet the faculty because they've probably only had one or two up to that point. And so yeah, we have a variety of things to help build community in the department.
Awesome. That sounds like a great time. Um, if a student wanted to pursue a major in physics with a focus on both nuclear physics and quantum mechanics, is that advisable or should they focus on one to pursue?
Yeah, I mean, it's perfectly fine. We don't have many nuclear classes. So the nuclear knowledge would more be gained from the reactor program. And then there's possibility of doing either thesis or an independent study in nuclear physics.
Great. Do you find students feeling burnt out, especially in their junior and senior year? What do you think the major cause of some students feeling burnt out, if that is a occurrence, versus those who don't?
Wow. I guess I wish I knew. Yeah, I've had advisees who feel burnt out. Can I come up with the reasons why some people are and some people aren't? I don't know. That might go beyond my ability to put the finger on the reason. Um, but I think, what do I think? I do think, right, as I pointed out, you don't have to take all those junior required courses in the junior fall. And I work with my advisees to at least mention, is this a good idea for you or not? And if there's any hesitation, I dig in a little more. And I think most advisors would. So it isn't common, but there are people who don't take that fairly heavy physics load all in the junior year. And it could be for different reasons. But if I had an advisee who was letting me know they had any starts of feeling of burnout by the end of sophomore year, that would be something I at the very least suggest, and is totally an option for delaying one or more of those junior fall courses to later in the senior year.
Thank you. And I'll also add to that is burnout is not a Reed specific thing. I think burnout is a college thing. I think that happens at college campuses across the country. I think kind of to Allison's point in the number of resources available on campus, right? Both within the department and beyond, to sort of help you manage this. Sometimes, and I had kind of a similar conversation with one of our admissions interns recently, where it was around like, are you taking on too much? And how do we how do we help you think about ways in which you feel comfortable setting boundaries for yourself, right? Because something that sometimes I think like we get like, and I'm this way too, and I think this is a characteristics of a lot of readies, where we just are excited about a lot of things and we want to do a lot of things and participate in a lot of things and are you're just excited and you're passionate, right? That's what makes you a good readie. But you also want to make sure that you're caring for yourself as well. Which fields of physics are probably the most research you're focused on in our physics department?
Um, that's hard to say because, right, all of the professors are doing research in their fields, and we all have like, 3 to 4 thesis students every year, and so there's a lot of research in all of our different fields, and then sometimes outside of it, is there one that's the most? I don't know, maybe we have 2 condensed matter theorists right now. Maybe that would win if you tried to count up the students per research topic. But it's not, it's not that we have sort of a hyper focus in any one research direction.
Awesome. Can you talk about the grading model here at Reed? I think infamously our grading model is it's a little bit more feedback focused than outright giving students grade. How does that sort of um, unfold itself in the physics department?
Um, yes, so we do still follow the Reed model of not being super explicit about exactly where your grade is as you go through the course, but we do, for any homework or quiz or test in our department, we give you the number out of the total points. So you know how you're doing via that metric on our work. But we don't update you partway through the semester, or even while you are graded at the end of the semester. It doesn't really come your way unless you make an effort to go and find that information. And so that's just to tune out that part of the side of things, which is the valuation, and try to keep the focus on the learning, try to keep it lower stress, and really to the important thing is to be learning these ideas and not worrying about every last point. But it comes to a time if many points are being missed, then we do have to let you know and let you figure out where the weak spots are. So specifically in the course I'm doing, I have a lot of little quizzes. So it's kind of constantly giving you this update. Did you get this bit of the course or not? And there's retests and there's a whole complicated thing I have going on, but I don't put the total on the front of the quiz. Why? Because I want students, the important thing about the quiz isn't like that number. The important thing is what you did and didn't understand on it, and if you still have more to learn from that quiz. And so while there's a number on every single sub problem, I haven't done the total, right, for the student to kind of look at and dwell on and stress about and compare to the neighbors and blah, blah, blah. That's not what it's about. It's about looking at that quiz, flipping through the pages and seeing what you did and didn't do right, and learning from the things you didn't get right yet on my next retest. So that's a more specific example, but in general, we do this grading, but we don't super stress about where you exactly what grade you're heading towards throughout the semester. It's more grading as a tool towards learning than grading for grading's sake.
What is your favorite part of being a professor here at in the physics department here at Reed? What do you enjoy the most about it?
Yeah, the fun days. I don't know. There's so many. I mean, I love physics. I love teaching physics. And so I love the days where just everything's in alignment. I'm teaching something I find really fun. The students get into it totally. They have great questions, and we just have like a great class. Those are the super fun days that I absolutely love. Thesis projects are probably like a second to that, but those, for me, those are my favorite days. Just like awesome jiving classes.
And what advice would you give to students who are considering our physics department here at Reed or Reed in general? What advice would you give students to to be successful when if and when they choose to come to Reed?
Yeah, like be curious. Look, show up, do the work, do the homework, learn the things, come to office hours if anything, if you have questions, if you're excited about something and want to know more. Just I'd ask you to come and be an active, engaged learner.
Awesome. Thank you so much. I know we didn't get to everyone's questions. I am putting the admission inbox email address in the chat box. Reach out and connect with your admissions counselor if you've got further questions or would like us to elaborate on anything additional. I do want to give a big shout out and thank you to Allison for taking the time out of what is a very busy term and providing us a ton of information and getting us a good glimpse of what you can expect being a future physics readie. To all the folks that attended this session, thank you so much for attending. I hope this was helpful and beneficial, and you all have a great rest of your day. Thanks, everyone.
Bye all.